So for the day 3 notes, what we're going to talk about is the law of cosines. And the law of cosines is another way to relate the sides and angles of a non-right triangle, but it's specifically used when we are finding information of triangles that are SSS, or side, side, side. So we're given all 3 sides, or side, angle, side. And the reason why you have to use law of cosines in these 2 types of problems is you don't have enough information to set up a law of sines. So eventually we'll have to, be fluent with both law of sines and law of cosines and know when to use them. But the quickest way to figure it out is if you try and set up a law of sines and you're missing too much information, or you're missing both an angle and a side you would need, then you would have to try the law of cosines. Now they look kind of complicated. So if you look at the law of cosines in standard form over here on the left, what I want to do is kind of show you the pattern. And I think helping you kind of see the setup will make sense of why it is the way it is. So if you look at the first one, a squared is by itself on the left side is equal to, and then notice how to remember the angle. It's the angle that's opposite of side A. So a squared equals, and then there's a bunch of stuff, and I'll kind of explain that pattern in a second, but it's going to be cosine of A at the end of that last term. So a squared equals, you'll have cosine of A at the end. And then what is the other stuff in there? It's going to be b squared plus c squared, which is your other 2 sides, and then minus 2bc, which are the same 2 sides that you have on that side. So again, if I'm solving for a, so a squared equals, I have the other 2 sides minus 2bc cosine of the angle that matches the side on the left side of the equation. And if you look at the other 2 standard form law of cosines, they follow the same pattern. So if I have b squared, it's going to be equal to a squared plus c squared, which are the other 2 sides, minus 2ac cosine of b, which is related to that side that's by itself, and then the third one follows that same pattern. And in standard form, we're typically going to use that setup for the law of cosines when we're trying to solve for a missing side. And the reason why I say it's easier to use when you're solving for a missing side is, if you look at what's all by itself on one side of the equation, it's a side. Lowercase a, lowercase b, lowercase c. To set this up, you would need to know b and c and angle A for that first line, or for the second one, b squared by itself, you would need to know a and c and the angle B. So that's going to be the most useful when you're solving for a side. But if you look at to the right there, the law of cosines alternate form, that's going to be the setup you would want to use if you're solving for an angle. You're finding a missing angle. The way I remember that is cosine of A is by itself, which means you're going to be finding angle A, or cosine of B is by itself, you're going to be finding angle B. Or cosine of C is by itself, and you're going to be finding angle C. So look at the pattern there. So the first one, cosine of A, is going to be equal to, it's going to be b squared plus c squared minus the side related to the angle. So b squared plus c squared minus a squared in the top. And then in the bottom, it's what was the coefficient of cosine of A in the standard form. The alternate form just comes from taking the standard form and getting cosine of A by itself. So algebraically getting cosine of A all by itself, you'll get the alternate form. So you can try and, obviously look at the pattern and memorize both ways. Or if that looks a little daunting, it looks like that might be difficult, if you just know the pattern for the standard form, you can set it up as is, and then you'll have to do a little bit of algebra to get the angle by itself. You can approach that either way. For the sake of the notes here, I will use both the standard and alternate form depending on what the problem is telling us there. And one thing I do want to point out is when we're using the law of cosines to find missing information, when you start using the law of cosines to find a missing piece of information or solve a triangle, finish the entire problem using the law of cosines. So don't switch back and forth between law of cosines and then try and set up a law of sines. It can be done, but you could potentially create a situation where you have an angle that has more than one solution, and it becomes a little more difficult when you switch back and forth between the 2 different laws. So if the original given information can be used with the law of cosines, then finish the rest of the problem using the law of cosines. That way you don't create a more difficult problem for you. And we'll explain a little bit more of what that looks like in the notes in day 4. It's called the ambiguous case, but for now, it's just a little more straightforward to say, if I'm going to use the law of cosines, then I'm going to do the whole problem using the law of cosines, and I'm not going to jump back and forth between the two laws, because it does potentially create a more difficult setup. So if you take a look at example 1, the first thing you might want to do is draw a triangle. So I'm going to draw one here, label it ABC, and then put the given information that I have on there. And then the second thing I would do is kind of identify what type of triangle it is. So I'm going to create my chart here, same way I have been before. So angle A, angle B, angle C, and then just fill in the given information. Again, that's not a necessary step. It's just something I like to do to get all my information in one place. Makes it easier for me to organize it and easier for a grader to kind of see what's going on here. Second thing, like I said, I want to identify what type of triangle this is, whether it's a side, 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 or a side, angle, side, which will tell me if I can use the law of cosines or not. And this, if you look at the triangle, I have a side, an angle, and a side. I have the angle between the two sides. So it's an SAS triangle, which means I can use the law of cosines to solve this triangle or find the missing information. So what I'm going to do is find side A, because I have B and C, and I have angle A, so I'll be able to find that third side using the law of cosines. So I'm going to write the generic standard form for the law of cosines to find A. So A squared equals B squared plus C squared minus 2BC cosine of A. So that's just the standard form rule to find A. A is by itself, and then the rest of the information is following that pattern for the law of cosines. And then at this point, you plug in everything that you know. So I know side B, I know side C, and I know angle A. So my setup would be A squared equals, and I'm going to put 31 in for B, 13 in for C, and then angle A is 60 degrees. So that would be my setup. And then from there, you could type all of that as is in your calculator and get a value for A squared. I'm going to kind of do an intermediate step just so I'm clear on where these numbers come from. So 31 squared is 961, 13 squared is 169, 2 times 31 times 13 is 806, and that's 806 cosine of 60. So that 806 is attached to the cosine of 60. So please be sure here you don't subtract 806 from 169 because it is attached to that cosine of 60. It's a coefficient. So to solve for A, I would just put that line in my calculator, 961 plus 169 minus 806 times the cosine of 60. They are attached, and what I would get is 727. So to find A, I would just take the square root of both sides, and A would be 26.963, so rounded to 3 decimal places. So that is a law of cosines set up to find a missing side, so now I have side A. And then, if you look at the information I still am looking for, so I'm looking for angle B or angle C, and once I have one of those other two angles, I'll be able to find the third one using the fact that all three add up to 180. So what I'm going to do is find angle B using the law of cosines, but I'm going to use the alternate form here because I'm going to get cosine of B all by itself, and I'll be able to put the information in that I know and find B. So here's the general setup. So this is the alternate form just generically. So cosine of B equals A squared plus C squared minus B squared all over 2AC. So if I put the information that I have A, C, and B. So I'm going to put those pieces of information in. 26.963 squared, 13 squared, minus 31 squared, all over 2 times 31 times 13. So cosine of B, so what I'm going to do is put that entire fraction in my calculator. Again, I'm going to be in the habit of making the entire top in its own set of parentheses divided by the entire bottom in its own set of parentheses, just to be sure that I'm not incorrectly applying the order of operations. Because if you type it and you miss a parenthesis or you put things in the wrong order, your calculator is just going to do it following order of operations, and you may get the wrong value. That's the one downside of having this be, very calculator heavy, is you don't know whether your answer is right or not. So please be sure when you have a big fraction like this, put everything in the top in its own set of parentheses, divided by everything in the bottom in its own set of parentheses, and you'll be sure that you don't make a mistake there. So what I would get as a value for that is negative 0.0, or excuse me, negative 0.0806. And then to find angle B, I would just take the inverse cosine of that number. And what I would get for the angle is, angle B is going to be 94.625 degrees. So this is a law of cosine setup, but it's using the alternate form so that I have B, or angle B, by itself, and I'm just putting all the information in on the right-hand side. So then finding angle B, I would take 94.625, put it in my chart there, and then if I want to find the last angle, I'm just going to use the fact that they should all add up to 180. I'm not going to create another law of cosine setup. The easiest way is just to subtract those two angles from 180. And I'm not going to, usually when it's a long decimal or more than one or two places, if you could see what I wrote here, I wrote angle C equals 180 minus angle A minus angle B. Obviously, you're going to put those numbers in there. I just don't want to rewrite it every time. And you don't even have to write this step. I'm just writing it to be thorough on where this number comes from. So what I should get for angle C is 27.375. And that is the completed problem using the law of cosines, both the standard form and the alternate form. And then for example 2, I'm going to take a look at the triangle that I have. I'm given side A, side B, and side C, and I'm going to find the rest of the information. So it might be helpful to draw a triangle, label it ABC, and make sure you label the sides opposite the angles correctly. So if angle A I put at the top, that means the side opposite should be 27, side opposite of angle B should be 19, and the side opposite angle C should be 24. Notice this is a side triangle, or at least we have all three sides given, so I'll be able to use the law of cosines here. But notice we don't have any angles, so I'm going to use the alternate form throughout this entire problem to find the angles. What I mean by that is I'm going to have to find the angles while given all three sides. So it'd be most straightforward to use the alternate form of the law of cosines. You don't have to. But if you do, then it saves you some algebra of having to get the angle by itself after you plug all the information in. So here's my chart here. I'm missing all three angles. So I'm going to find angle A first. So the generic formula for cosine of A would be B squared plus C squared minus A squared over 2BC. So all I need to do is put A, B, and C in the appropriate place, and I'd have a value for the cosine of A. So if I put 19 in for B, 24 in for C, 27 in for A, here's what I would get. So cosine of A is equal to, and again, I'm going to put the entire numerator in its own set of parentheses and the entire denominator in its own set of parentheses and get a number for the cosine of A. So what I would get is 0.228, that's rounded to 3 decimal places. And then if I want to find the angle, I would take the inverse cosine of 0.228. So angle A is going to be cosine inverse of 0.228. So angle A is going to be 76.817 degrees. And I'm going to take that angle, put it in my chart, and I found one of the missing angles that I'm looking for. You could put it in a chart, you could put it in the triangle, or you could put a box around it. Either way, just show me somewhere that you found a piece of information so I know where to look. Now, I can't find angle B and C yet. I have to do another law of cosines, and I'm going to use the alternate form again because I have the angle by itself when I use that form. So I'm going to find angle B. So here's the general setup. So cosine of B is going to be A squared plus C squared minus B squared all over 2AC. And then I'm going to put the information I have for A, B, and C in there. So I would get 27 squared plus 24 squared minus 19 squared all over 2 times 27 times 24. And what I'm going to do is put that in my calculator, put the entire numerator in its own set of parentheses, the entire denominator in its own set of parentheses. Notice I am obviously trying to be straightforward here and repeat that just because I'd hate to see you set it up correctly and then type it in your calculator wrong and miss a problem that way. So what I'm going to do next is write cosine of b equals whatever that number is for that large fraction. And what I would get is 0.728. And I'm writing a rounded decimal, but when I'm actually calculating, I'm using the full decimal answer. I'm not putting 0.728 in. I'm taking the inverse cosine of my previous answer unrounded. That way I can be sure that my angle is as close to the true angle as I could possibly get. So angle B is going to be cosine inverse of 0.728. So angle B is going to be 43.248 degrees. So I used the law of cosines again in the alternate form to find angle B, and I'm just going to put that in my chart there. And then I have two angles. I can find the third angle by using the fact that they should all add up to 180. So angle C is going to be 180 minus the other two angles. So angle C is going to be 59.935 degrees. And that is a law of cosines when we are given all three sides. You can use the standard form or you can use the alternate form. When you're looking for angles, though, the alternate form is going to be a little bit easier algebraically. You won't have to solve for anything. Please make sure that when you get down to the value, you're using the inverse cosine of that value because you're looking for an angle. And once you have two angles, you can find the third one just by subtracting them from 180.